Now piecewise function is a function which is defined differently for different points of value of x. For example, in entire interval, function is defined in various parts actually. I'll give you one example to explain it further, that my fx is equal to, now it's not a single definition of fx like normal function. For example, fx equal to x square is a parabola which is a normal function. Now piecewise function is defined something like this: fx is equal to 3x square, let's say if x is greater than 0, and is equal to x if x is equal to 0, and let's say 2x plus 1 if x is less than 0. So although the domain of this function is entire real line, because the function is defined for x greater than 0, equal to 0 and less than 0, but it's not uniquely defined. Like for x greater than 0 it has a different value, 3x square. For x equal to 0 it's x, and for x less than 0 is 2x plus 1. So this is known as a piecewise function. Now suppose I have to find the value of this function at various points. Suppose I want to find the fx as x is equal to -3, x is equal to -1, x is equal to 5, x is equal to 7, or let's say x is equal to 0 also. So when I have to find these values at various points, now how to find these functional value of a piecewise function? Now if you have x equal to -3, what you have to do is you have to choose a definition which is satisfying this value, that is x is -3. Now this, no, you cannot choose it because x is positive. X is equal to 0 again, x is less than 0. For x less than 0, this is the value. This is the value of the function which you have to take. Now, so what will be my f of -3? F of -3 will become -6 plus 1, that is -5. Similarly, for -1 also, again I will use this definition only. X is equal to 5, now not this definition, because x is equal to 5 is satisfying the condition that x is greater than 0, and therefore one has to use this one. And for getting f of 5, you should take this value, in fact, this function value, and therefore I'll substitute x here, plug in this x is equal to 5 here, and that will give me 75. Similarly, for x equal to 7 also, again you have to choose the one where this x equal to 7 satisfies the condition. So this, again, the first one only. X equal to 0, you take the second one, and therefore the value will be 0. So f of 0 will become 0. Now these piecewise functions again are important, because while drawing the graph of these functions, one has to take care of various things. For example, let's take a question where fx is equal to x if x is greater than or equal to 0, and minus x if x is less than 0. Now here you see that this function is modulus of x, basically fx equal to mod x. So once you are drawing the graph of this function, you have to be very careful about these two definitions. So when x is greater than or equal to 0, it's x, and therefore I'll draw the graph like this. Not here, you see, otherwise fx equal to x will be something like this. But the definition that fx equal to x is only possible when x is greater than or equal to 0. So that's my graph, only this first quadrant graph. Fx equal to -x if x is less than 0. So if fx is this side, it will be something like this. So my final graph of fx equal to x when x is greater than or equal to 0 and minus x if x is less than 0 is this one. So be careful while drawing it, because you can't take this portion, that is not valid as far as piecewise function is concerned.